Welcome to the Basement Series Deep Dive, getting you the skills and knowledge to really fix problems. And in this instance, we're going to help you fix your home network. Because hey, let's be honest, home is where the network connects automatically. And that's what we're going to fix in this episode.
So what is the agenda for today? We have a quick introduction. Who am I? What are we going to talk about? Then we will have an overview of the 7 fails. We will look into how to prevent those fails and what you can learn from it. This is how to improve your home network, and then where can you go for finding additional information. Because this session is all about working from home, and home is where we are. As you can see in this report, as of March 2020, when the global lockdown was announced, a dramatic increase in bandwidth usage. Both the upload and download usage went up significantly. Why? Because everyone is joining in those video conferences from their homes. They're attending WebEx and Teams and Zoom calls, and some people are crazy enough to build an entire film studio in their basement just to have interviews with awesome people from the industry. It's called the Basement Series. You will hear about it very soon. Anyway, work from home is here to stay, and that's why it's so important to have a decent home setup. And that's exactly what we're talking about today. So who am I? My name is Heinsius. I worked as an end user for many years. I worked at a water facility company in the Netherlands. I worked as a field engineer with a partner doing Call Manager and Call Manager Express installations. I worked for a distributor. Now I work for Cisco since 2010. And I've been a CCSI, a Cisco instructor, for 16 years already. In my spare time, I'm a dad, I'm a husband, I'm a runner, I'm a cook, I'm a mountain biker, I'm a scuba diver, I love snowboarding, I'm a singer in a ska reggae band, and I'm a Wi-Fi enthusiast. So I am one of those people that walks into a building and looks at the ceiling where the access points are installed. And I'm pretty sure I'm not the only one. So how did this session start? In 2016, I wanted to create a best practices overview of Wi-Fi. And it was the most boring session ever. So I decided, you know what? I'm going to flip it around and I'm going to tell you how to do it wrong. And the result of that is that if you understand what's wrong, you can actually learn and improve it to do it right the next time. So I submitted 7 ways to fail as a wireless expert to the Cisco Live organization. And they said, are you sure? Are you sure you're going to submit a session called 7 ways to fail as a wireless expert? No one will sign up. Well, in fact, it became actually one of the most popular sessions. And by now we have the 7 ways to fail. We have the 7 new ways to fail. We have the 6 on Wi-Fi 6, so a total of 20 fails. And the session you're looking at right now is the 7 ways to fail for the home environment. So it's a brand on its own now. Because working from home is what we're all doing right now. And what you really see, that 2020 was the year of change, and a lot of things has changed. But one of the things that has changed and will change forever is the way we work, where we work, how we work, with what devices we work, and so on. And that, again, is the reason why we need to improve that home network. Because what you can see here, this is what you see in a lot of home installations. Where I'm asking, where did you put your access point? Where did you put your router? Probably a lot of people think it's the same device. They will point me, this is where they put it. They put it in the closet where the internet service provider put it. And as you can see, they put a whole lot of stuff around that, and that is really not how to do that. In order to understand why this is wrong, you have to understand the basics of Wi-Fi. So that's what we're going to look at right now. As you know, there's the standard 802.11, which became a standard in 1997, and then we had all the amendments, A, B, G, N, AC, AX, and so on. There's 2 frequencies, there's 2.4 and the 5 gigahertz frequency, and they have their own channels. We will zoom into that in a minute. You also heard about a thing called Wi-Fi 6, and you might think, what is Wi-Fi 6? You just had the alphabet soup. Wi-Fi 6 is 802.11ax, okay? Because people thought that the alphabet soup was quite confusing. all those letters. So they decided we're going to use a numeric scheme moving forward. So that means that AX is Wi-Fi 6. So with that, 802.11ac becomes Wi-Fi 5, 802.11n becomes Wi-Fi 4, and so on. So that is where we are today. Wi-Fi 6 is the standard that's out there right now. Diving into the wireless basics. What's a frequency? You heard me talk about 2.4 and 5 gigahertz, and what does that mean? A frequency and the gigahertz. Well, 2.4 gigahertz basically means there's 2.4 billion of these red radio waves happening in 1 second. That's B with a billion, ladies and gentlemen. 5 gigahertz means 5 billion of those radio waves happening in 1 second. Okay, that's quite a lot of radio waves, I know that, yes. And social distancing is a thing. We all know by now that social distancing is important. We need to maintain that. But we as wireless engineers know that already for many years, because social distancing is exactly what we do with the channel plan. We will look into that in a minute. You basically separate out channels and keep a distance between them. One of the questions that we get a lot is Wi-Fi bad for health? And the short answer to that is, well, if someone throws an access point at your head, then yes, it might hurt you. Otherwise, no. And to really dive into that question, think about this. Who in the call uses its phone as an alarm clock in the morning? I'm pretty sure that you do that as well. About 80% of the people do that. They use their phone as an alarm clock in the morning. Is that bad? No, not at all. I'm doing it as well. Now let me ask the second question. Do you put it on flight mode? No. Most people don't put it on flight mode. There's only 12% of the people that put it on flight mode. Now, let's dive into some of the numbers. Your cell phone, your mobile phone, is transmitting on a GSM network, on the phone network, with 1 watt, which equals 30 decibel to the milliwatts, which equals 1000 milliwatt. Where we're looking at an access point with an RSSI to the laptop of minus 66 dBm, that equals 1/4 millionth of a watt. Okay? You are asking questions and concerns about that access point and the radio waves going to the client, to your laptop. Well, in fact, you are sleeping next to a device that is 4 million times more powerful next to your head. Just saying. Is that bad? I don't think so, but just saying. Now, this is an interesting number. If you take your iPhone and you put in this number that you see on the screen and you hit dial, you will actually see a secret menu that will tell you how is the connection between your phone and the antenna from your provider. So it will give you insights on how strong is the signal and all those data. So that's a very interesting one to do. I'm sorry, I don't know this menu for Samsung or for other Android devices, but this is the way to do it for an Apple device. I think that's fun. So you heard me talk about channels, and why are those channels important? Well, in the 2.4 gigahertz band, we have 13 channels available in EMEA. In Americas, you have 11. In Japan, you have 14. But I'm talking about the EMEA number plan right now. So we have 13 channels. And we say channel 1, 6, and 11 are the only ones that you should use because they're the only non-overlapping. But as you can see here, all of them are overlapping. Okay? So what is important to realize with 1, 6, and 11, they don't overlap with each other. Now, why is that important? We're going to go into your car, okay? So this is your car, and this is your radio station in your car. And in this car, you have 13 radio stations, and each radio station is broadcasting its own channel. So channel 1 is rock music, channel 2 is political talk, channel 3 is the sports talk, channel 4 is comedy channel, channel 5 is pop music, channel 6 is hip hop, channel 7 is classical music, channel 8, and so on and so on and so on. Now you tune into channel 7. And instead of hearing just channel 7, because all those channels overlap with each other, in fact you hear channel 5, 6, 7, 8, and 9. How nice is this radio station going to be? I'm pretty sure that quite quickly before you exit the street, you'll be like, let me turn off the radio. So because of this, all the radio broadcasters made an agreement and said, even though we have 13 channels available, we're only going to broadcast on 1, 6, and 11. So if you tune into one of those 3 radio stations, all you hear is that particular radio station. And that means that the sound that you will hear is much nicer. Make sense? That is why the non-overlapping channels. Now, we go to the 5 gigahertz band, and what you see here in the 5 gigahertz band is that we have way more channels, and as you can see, all of them are non-overlapping. That's awesome, because of that, we have more choice, we have more possibilities to use channels, but also every channel is 20 megahertz. So with that, we can actually do a thing called channel bonding. And with channel bonding means that we can combine 2 20 megahertz wide channels into one 40 megahertz wide channel. And we can do that again on the AC standard to go to an 80 megahertz wide channel. And we can do it again to go up to 160 megahertz wide channels for the AC Wave 2 standard. Sounds awesome, and it is. By the way, channel bonding was something that was invented as part of the 802.11n standard. So in the standard, it's allowed to use it on 2.4 gigahertz as well, but in reality, never use that. We will come to that in a minute. You heard me talk about the channels in the 5 gigahertz band. There's also a thing called DFS, and DFS is the dynamic frequency selection, which basically means that there are some channels that might hear, for instance, the radar or a weather station that might be pinging in that same frequency. If you have a DFS capable access point, which most enterprise grade access points are, they will pick that up and simply take out that particular channel so you can use the rest. In Cisco access points, we have flexible DFS, which results in, if you have, let's say, an 80 megahertz wide channel, instead of taking out all those 4 channels when it hears interference or a DFS ping, it will reduce only 1 channel and give you a 40 megahertz and a 20 megahertz channel back. So you actually have a higher selection. Some other words for you to know about that are important to realize. There's RSSI, which is the received signal strength indicator, which is a really important one to know how strong is your signal. RSSI is the main one that you do your measurements on. They are measured in decibel to the milliwatts, dBm, and usable range is typically between minus 50 and minus 80, where everything below minus 67, so closer to 0, is really good. Minus 50 is very healthy, and everything above minus 80 is a lousy connection. Another one to know is the SNR, the signal to noise ratio, which is measured in decibels. And the usable range is typically between 25 and 40. What does it mean? You have a noise floor and your signal should be higher than the noise floor. So what is the difference between the signal and the noise? That's the signal to noise ratio. As an example, when you are on the phone in your open office space and there are 100 employees around you and all of them are on the phone, then the noise floor is very high. So if you are on the phone talking to your customer on that open floor space, you will hear a lot of noise around you. So your signal to noise ratio is not enough to have a proper conversation with the customer. If you would have cubicles, the noise level would be down, so you will hear your customers better. And if you have noise cancelling on your headset, the noise level will be even further down. So you see that there's a difference between the signal to noise ratio. It's a really important one to realize how your connection is. All right, so let's jump into the fails. And we're going to start with the most common one. Fail number 1, forget about those channels. What you see here is a friendly fellow that parked his car on 2 parking spots. If you see this in reality, especially on a Saturday, you're like, thank you. That is exactly what happens with Wi-Fi. This is how it looks in Wi-Fi. What you see here, this is a scan that I did with Wi-Fi Explorer. You see channel 1, 6 and 11 and a friendly fellow that put an access point up in channel 4, taking out channel 1 and channel 6. That's exactly what happened here. By the way, I took this picture in a Cisco office. in Cisco UK, to be honest. So what you see here, the car parked on 2 parking spots, that is your access point on the wrong channel. Now, this is an overview of a channel scan in a multi-story building, like your apartment. A lot of people live in apartments, and if you do a scan here, what you see tens or even hundreds of access points, and all of them are competing on the 2.4 gigahertz band. If you zoom into the frequencies, you can actually see that all of them are overlapping. And another thing that you see here, the big green one, is channel bonding happening on the 2.4 gigahertz band. So the result of that is there's a lot of interference, and actually the connection will be really bad. What you see now is that if we move to the 5 gigahertz band, there's a lot more space. The second picture you see here, this is when you are doing a scan in your street, and you'll see similar views. So on 2.4 gigahertz band, very crowded, lots of overlap, lots of noise. 5 gigahertz, almost nothing. And we have to admit, we cannot manage the Wi-Fi in the entire building or the block, but there are a lot of things that we can do. So here are my first recommendations. In 2.4 gigahertz, please only use 1, 6, and 11. Plain and simple, don't use anything else than 1, 6, and 11. In the 2.4 gigahertz band, never do channel bonding, okay? Yes, a lot of the consumer grade providers have that, like D-Link, TP-Link, Ingenious, Ubiquiti, Linksys, Belkin. They support channel bonding in the 2.4 gigahertz band. Why? It's all marketing, because you can put a higher number on the box. You can say, I can run 300 megabits per second on the 2.4 gigahertz band, way better than all those enterprise providers. Yes, by providing channel bonding. If you live in a little farm in the middle of nowhere with no neighbors, go for it. Channel bonding works fantastic. If you have neighbors, and I'm pretty sure you do, don't use channel bonding, okay? Simple as that. My best recommendation is move to the 5 gigahertz band. Really, really simple. Everyone will benefit, okay? Move to 5 gigahertz. And you might say, but my internet service provider is the owner of my channel plan. Give them a call and say, dear service provider, question 1, can you enable my 5 gigahertz band? Question 2, I see that you put my access point on channel 7. Can you move it to either 1, 6 or 11? Okay, everyone will benefit. And when you have a problem with your Wi-Fi, I'm pretty sure your neighbors have a problem as well. So my recommendation is reach out to your neighbors. Make a channel plan with your neighbors and simply say you're going to be on 1, 6, 11, 1, 6, 11, 1, 6, 11. By doing so, everyone will have a better connectivity. Okay? Everyone will thank you on the next street barbecue when we can actually go outside and have a barbecue again. So I want you to recommend to do a test like this. These are 2 websites, speedtest.net, which is owned by Ookla, or Speed of Me. You can also do a scan on the QR code. It will bring you immediately to the website. You can do the test on your phone, and with that actually see how the performance is from that particular device. Now, how should you read that report that you're getting? The first number that you need to look at is your ping speed, okay? This is an important one. It should be a low number. Very healthy is anything below 10. So that means that you have a very high ping speed, you have a good response time, and if you have any gamers in the house, they will love a low number like that. Is the number somewhere between 10 and 30? That basically means that you probably have too many walls in between your client and the access point. If the number is higher than that, you have an issue. Okay, so that means that you have some connectivity issues. The second number that is important to look at is your download speed and your upload speed. They should be in line with the contract that you have. If this number is completely off, again, it could be because your access point is too far away, or it could be because you have too many clients on the same access point and they're actually generating a lot of data at that time. So Some best practices. Do this performance testing. Simply do it on your phone and on your laptop. Do it on several spots in the house. It will give you a first indication. Is my network properly done? Yes or no. What can you improve? Channel 1, 1611, no channel bonding on 2.4, and move to 5 gigahertz as much as possible. All right? So simple rule number 1, choose free channels. It's that easy. All right, move to fail number 2. All your eggs in one basket, because treating your business Wi-Fi the same as your home Wi-Fi is not the way to do it. You can make improvements here already for your own network. So what you're seeing here is your own home network, and this is you. And you have your devices. So you have your phone, you have your laptop, you might have an additional device like your iPad that you're working on. And you probably have a partner is working from home as well, has a laptop and is connecting to the same infrastructure. You might have a kid, maybe you have more kids. They have their own devices and they might have like an Xbox or a Switch or a PlayStation. And then you have your light switch, you have your audio speaker, you have your doorbell. All of them are now connecting the Wi-Fi. They're taking airtime from the Wi-Fi and they're treated all the same. Unfortunately, it doesn't stop here because you also have neighbors and your neighbors are contending for the same airtime and you probably have more neighbors. So all of them add on to, here we go again, the noise level. So what you want to do, this is the best practice, is that you separate out your business SSID, so your business network. You will have a separate SSID where you're connecting all your IoT devices, so your camera and your speakers and your TV and all those are connected to their own SSID. And then your kids will have the rest SSID. That will be the lowest priority SSID. It might be that your kid is doing homeschooling as well, and for that particular instance you could use a separate SSID just for the homeschooling that has a higher priority. But what you don't want is that your video call is being degraded by TikTok or Netflix or YouTube streams in the house, which is a lower priority than your business call. So separating out the different types of traffic and separating them out based on the SSID is really a best practice, and you can do this already with your existing access point, okay? So, best practice, separate out your groups of clients, and another recommendation is do not use more than 4 SSIDs. And when you have separated them out, you can simply prioritize the traffic. So fail number 3, hiding your access point. Well, you tell us that access points are ugly. Okay, I see why you say that. Sometimes some of the access points indeed are. And what can you do with things that are ugly? Well, here are some examples of things that I think are ugly. You can tune them. But they still look ugly in my opinion, right? They look cool and funny, but ugly. By the way, before we make any more jokes about Lada was actually the first company that had onboard Wi-Fi, okay? So give them some respect. Make sure your access point is close to the client. So I asked a couple of my colleagues, all the pictures you're gonna see now are Cisco colleague home environment networks. I asked them, where do you have your access point? I'm going to share with you the pictures. I got answers like where my internet service provider connection is entering my house and doing that the nice and proper way or the hang in there method. Okay, these are real pictures. I have a colleague that invented wireless stacking, putting 2 access points on top of each other to have a better coverage. I have seen instances where they put the access points in a central spot in the apartment and cover the entire apartment. So these are 2 access points from one colleague, and they are 2 different vendors, 2 different networks. So this is really a no-go. Always use your equipment from the same vendor, because in that way they can work together, they can interact, and they should be also registered to the same controller environment. In this instance, the access points actually compete. Okay, they are saying I'm important, no, I'm important. And even though you have the same SSID, so the same Wi-Fi name on top of them, yes, you can connect to both of them, but it doesn't support roaming because there are two different access points from two different vendors that handle the roaming in a different way. So that is not how to do it. Recommendation, if you need to have two access points, which is absolutely fine, but make sure that you use them from the same vendor. Okay? And ideally access points that support multiple access points, because not all the consumer grade access points support that. It starts at the workspace, and I fully agree on that. In your workspace environment is where you want to have the best connectivity. So you want to have, like I always say, you want to stay close to your client. So you want to have access point close to where you are working and where you are doing your video calls and where you are participating in your meetings. So don't put your access point all the way down the hallway when you are working in your office. Recommendation is to put it in the workspace. And some people actually hide the access point next to their desk, and they're all options. We have Team Aeronet, so we have some colleagues that have Aeronet access points. This is one colleague that was really proudly showing me his Power of Ethernet switch, and then I said, but there's no wires in it, so you're not using it. He's like, oh, you got me there. So a lot of our colleagues use Aeronet access points, and of course we also have a lot of colleagues that use Meraki access points. Here an example of an access point put in front of the television, which is actually the access point that covers the living room area. So as you can see, the recommendation is put your access point where the client is. I like this picture. It says polarization matters, because polarization is the way radio waves move. So let's say my thumb is now a radio antenna. That means that my hand represents the radio wave as it moves. And access points that are ceiling mount should have the polarization with the antenna pointing down or up, because that gives us the right polarization. If I put a ceiling mount access point on the wall, I have the wrong polarization. You see? That gives us a horizontal polarization, and that's not what we want. So putting the right access point on the way it should be installed is an important one. So ceiling mount should be either to the ceiling or pointed upside down, laying down, and wall mount should be installed on the wall. We have mix and match, so colleagues that combine Meraki access points and Catalyst access points, and we have Team Linksys, because there's still a lot of our colleagues using the original Linksys equipment, which is, as you can see, still very common to be used. But when you buy a home Wi-Fi router for your enterprise, this is what you get. And when you are buying an enterprise Wi-Fi in your home network, this is what you get. So it does matter what you're working on, and what is really most important is where do you put the access point. So I'm going to show you my home network setup. So this is the house that I bought in August, and I took my favorite tool, Ekahau, to do some designing and say, okay, where am I going to put my access point? Well, the access point comes in on the wiring closet on the ground floor. That's where the internet connection comes in. And then I was figuring out what are my favorite spots to be working. So my number one favorite spot is the kitchen table. You as well, I know you do. My second favorite spot is my office. The third spot is on the couch in the living room, and the fourth spot is on the restroom. No, not you, not you. I know. Everyone else does, but not you. So these are the four spots that you really want to have good connectivity, right? So if I take my access point and put it on the spot where the internet service provider enters the house, and this is what most people do, okay? This is the connectivity that you get. And as you can see, my number one favorite spot, the kitchen table, I will have no connectivity. Spot number two, my office, I will have some connectivity, but not too good. Spot number three, the couch, I will have some connectivity, but not too good. My only spot that I have proper connectivity is the restroom. Okay, so this is not how to do it. So what if I move my access point now to the living room? As you can see, I have a much better connectivity now. So I will have decent connectivity on my kitchen table, in the living room, even the restroom. I have some connectivity, I just don't have connectivity in the office. So what should I do? Take two access points, one in my office and one in the living room. And as you can see now, I have fantastic connectivity throughout my entire ground floor and including up to my garden. So this is actually how my network is set up in my home. You might not have sophisticated tools like I have with the Ekahau, but there are a lot of tools available that you can do some decent investigation. I already gave you speedtest.net and Speed of Me. These are two other tools that I really like. So I like the Wi-Fi augmented reality for Android and the Airwave augmented reality for iOS, which basically gives you an opportunity to walk around through your house and then you see the RSSI that we talked about. So how strong is the signal and what would be your average data rate. So these are free tools, really fun to use, and it gives you a good indication of how the performance is in your house. Why is that so important? Well, if we're looking at Wi-Fi, and we're going to go back into the basics of Wi-Fi again, we have a transmitter and a receiver. But as you probably know, in your house you will have different materials. And what we see most common in the house is cylinder block, brick wall and concrete wall. Okay, those are the three main ones that we look at. If I take, for instance, my house is cylinder wall and concrete wall. And as you can see, the attenuation of that is really strong. So it absorbs the signal. What we also see in a lot of apartments is that access points or the internet connection is wired into a metal closet. Physics, anyone? Faraday's cage. Putting an access point in a metal cage is not the ideal spot. And what we also see is that a lot of people have aquariums, and an aquarium actually absorbs the radio waves. Anything water absorbs radio waves, and keep in mind that a human body is also a bag of water. We all are, so we all absorb radio waves as well. So that is something to keep in mind. Putting your access point and away from your clients and having a wall in between, the result of that is that actually the signal will be a lot less. And especially if you have to go through two walls, you will see that the signal will be a lot less. So going back to my initial design where I said, okay, this is my floor plan. The internet connection comes in on the wiring closet on the ground floor. If I put my access point there, the kitchen table, I will not have proper Wi-Fi because what you see here, the signal had to move through two walls. And that's the reason why it doesn't come there. A complaint that I hear a lot is my internet connection comes in on the ground floor, I put the Wi-Fi over there, and in the attic I don't have connectivity. Can I put a wireless extender? Can I put wireless repeaters? Please, let's all agree to never use wireless extenders and wireless repeaters again. Simply buy a second access point and put it in there. Okay, they don't have to be expensive. You can buy a cheap access point, but you will have so much better connectivity. And a second access point is not the same as a wireless extender or a wireless repeater. Okay. Best practice. Where do you put your speakers for your audio system? If you're listening to music, you have a speaker close to you, right? Because then you hear the music nice and clear. You're not going to put the speaker in a closet. You're not going to close the door. You're not going to put the speaker in another room for you to listen to the music in this room. Why? Because the sound doesn't sound good. The same goes for your Wi-Fi. Put your Wi-Fi where the clients are, okay? So the best practices: put your access points close to the clients. If you can see your access point, you are in the best position. And the simple rule that I have here, make sure you can see your access point. If you can see the logo, you're probably good to go. So, fail number 4. I don't have interference. Because interference is something that happens in the industry. That's something business, and I'm a consumer. I'm a home user, so I don't have interference. Well, in fact, interference is something that's always been around. And we know interference in an office environment where it's very common to see Bluetooth interference, cordless phones, we see headsets, those devices could be interfering. But in your home environment, you will have a microwave oven, and a microwave oven is a severe source of interference. You might have a video baby monitor. Oh my, you don't want to know how much interference comes from a video baby monitor. Motion detectors, all of them add on to interference. Do they have an impact? Absolutely. I've shared with you a lot of videos on YouTube where you can see all those different sources of interference. So they have a dramatic impact. So the best practice here, stay away from your interference. It's as simple as that. Move away from there. Simple rule number 4, have your AP away from sources of interference. So putting your access point on top of a microwave oven is not really the best practice. Okay. So fail number 5, underestimating security. Even you as a home user, security is really important. Okay. And putting your device on the default username and password is absolutely no-go number 1. That is like hiding your key under a see-through doormat, okay? The first thing that you need to do is change the default username and password. A website I can recommend you to have a look at is wiggle.net. On wiggle.net you can find your home address, you can probably find your home Wi-Fi, and what is interesting to see here is that only 67% of all the wireless networks registered in the world are properly secured. That means that there are still a lot of networks that are not secured. And that is what I want to change with you. I want you to properly secure your network, including your home network. And you might think, but passwords are so difficult. This is a little trick. Set your password with at least 10 characters, but in order for you to generate something that is difficult to crack in a dictionary attack, but at the same time easy to remember for you, use a sentence or use a song or use your favorite movie or use your favorite television series. In this case, I took 3 songs. I took a song by Billie Eilish that says, "You should see me in a crown." I have Empire State of Mind by Jay-Z, and I have a song by Bruce Springsteen called Born to Run. It might be your favorite song, and by writing it like this, it's easy for you to memorize. It's easy to hand that password to a friend or a guest. And at the same time, it's very difficult to do a dictionary attack on it, because in a dictionary, this doesn't make sense. Okay? So these are examples of how to create and generate a password that will be accepted by those difficult password algorithms, and at the same time are easy to remember. Second step in security, you can connect to OpenDNS. You in a business environment know this as umbrella, which basically means that all traffic will be checked if the source or the destination is legit. If you click on a website or a link, it will check, maybe you shouldn't go here, and it will inform you. All you need to do is change the DNS settings, okay? So instead of 8888 or 8844, which are your Google DNS settings, simply change those DNS settings to these. It's free, it's fast, it's reliable, and most important, it's secure, okay? If you want to take it a step up, you can even set up a family account on OpenDNS. Again, it's free, and you can even give in keywords that you don't want your kids to be using, for instance. So you can take it one step up if you want. But use Umbrella also for your home network, but also if you work for a charity, if you work for a primary school, use it. It's free. Everyone will benefit if we all improve security on the internet. So the best practices here, please always use WPA2 encryption, okay? Don't use web, don't use open networks. If you have wireless extenders, some people use wireless extenders. I'm not a fan, but if you did, please make sure that you secured them as well. I see that as a very common mistake. And change your DNS settings to OpenDNS. So simple rule number 5, always be protected. We go into fail number 6, taking it all too serious. I like making a little bit of joke, and you can do that on your Wi-Fi as well. So be creative. Here you see Pretty Fly for a Wi-Fi, a song by Offspring from the 90s. Head away, what is love, baby don't hurt me. I really like the Abraham Linksys. Make fun with your SSIDs, go for it. The way I set up my own private network, my own network, I have my Sunflower, that's my own network. I have my Cisco CVO network, which is the Cisco Virtual Office. I have my IoT network where I have all my lights, my streaming, my Apple TV, my TV and so on. And then I have my kids network. They call it the poop network. and that has a connection, and they actually like showing this to their friends, like, look how we call our Wi-Fi network. You can change the settings with that. So yes, you can use emojis as an SSID. If you want to do that, you can simply take the Unicode overview with emojis and copy paste them into your SSID name. It looks cool, it looks funny. However, I want to warn you, older devices might be challenged connecting to it. So if you have an older Android phone or if you have an older Windows machine, they might be challenged by connecting to the emoji SSIDs. So if we go back to my home network, you see that I had 2 networks with SSIDs and 2 with text. So best practice, use the different SSIDs, but a maximum of 4, and make a little bit of fun. As we say in the Netherlands, life is a party, but you gotta bring your own decoration. So we're gonna look at fail number 7. I don't need to update because my router from 2007 still works. Yes, it does still work, but let's be honest. If you see an update on your phone, we all update immediately. Why? Because it will give us faster, more reliable, more secure. It's really important to maintain those updates and keep following those updates, right? And the same goes for your environment, because even though I absolutely love this friendly fellow, it's the WRT54G, I installed tons of them in all uncles, aunties, grandpa, granddad, parents' houses, all my friends' houses. Everyone had this one, but at a certain point it's time to say goodbye. Okay, so I see a lot of people that are still on the 802.11n standard, which is known as Wi-Fi 4, which basically means that you are living in 2009. And in 2009, this guy was still alive. In 2009, it was the first time you could go for a gay marriage in Sweden. In 2009, you could buy a Bitcoin for less than €1. I wish I did. Oh my God. And in 2009, this would be your phone. Are you still on this phone? No, you're not on this phone anymore, so you should go upgrade. But I've seen worse. I've seen people that are still on 802.11g, Wi-Fi 3. If you are on 802.11g, you are living in 2003. In 2003, Arnold Schwarzenegger became the governor of California. In 2003, Cristiano Ronaldo had his debut playing for the Champions League. And in 2003, you could still fly on the Concorde. And in 2003, Lance Armstrong won the Tour de France. He was still a hero. So, as you can see, it is time to upgrade, okay? Because today is Wi-Fi 6. Wi-Fi 6 is the standard, and even if you are in a home environment, I can guarantee you will benefit from Wi-Fi 6. So, where can you find your equipment? If you're a Cisco employee, you can order your CVO, your virtual office, or you can buy Meraki in the employee store. If you're a Cisco partner, you can use the Not for Resale program. If you don't have that program, you can click the link and you can go to the online store to buy Meraki Go. If you're a Cisco customer, you can actually take out your old access points from the office, upgrade them to Wi-Fi 6 and take the old access point and reprogram to what we call Office Extend. And with Office Extend, you can actually use that access point in your home environment and have all the benefits from your office environment in your home. If you are a non-Cisco customer, my recommendation would be to go to the online web shop and buy Meraki Go. It will give you all those advanced features that we talked about in this session, and it is very decently priced to actually buy for a consumer. So best practices, if you're working on the router from your internet service provider, please do yourself a favor and upgrade to your own access point. You can put that access point on a spot where you want it and you will have so much better connectivity. You'll be happy, your partner will be happy, and I'm very sure that your kids will be even happier. So with that, simple rule number 7, like with your phone, upgrade and update. That's all, folks. That's all I had to share. I hope you enjoyed, and I hope to see you next time again in a real environment and we can actually shake hands at the end of the session. All right. Thank you very much. Thank you for your attention and enjoy the rest of the show.